All right, this is Ryan Zhang from APAC Service Team. This is about the agent security demo series, specifically on running agent with OpenShell. I'm going to run through some concept before I jump into the demo. First, let's have a look at some generic OpenShell architecture and workflows. As a user, you usually will running an OpenShell CLI or SDK to interact with the OpenShell gateway. OpenShell is using the control plane and data plane architectures. In this demo, both were running on OpenShift. Let's say user want to create a agent with a sandbox environment, and then the user will send the request, and the gateway receive that and will start to provisioning a pod. And so the agent will end up running in a OpenShift pod. Inside this pod, there's a container. Inside this container, there's multiple processes. One is a supervisor process, which will be the security guard of this sandbox environment. It will start to provisioning a child process, which is our agent process. This agent process will running under Linux security mode. It cannot have access to the root, and it cannot utilize the sudo, etc. And it also have to comply with the file system policy, network policies. No matter this agent is executing, so the file system and network policies are guardrails by this OpenShift policies. For example, the agent want to access the external or internal APIs. The policies will check the definition and either allow or deny this request. Another use case is the agent want to access the large language model. It will have to go through the inference router. The benefits is that you configure the large language model credentials and configurations in the gateway, and the agent will not access it directly. So it will protect that. And another case is that you can see in the sandbox part, it has a different runtimes. It can have a ordinary container runtime. It also have a capability of using the micro VM. I'm going to demo this as well in my demo. So, okay, with understanding how agent sandbox part will be provisioning and run, we also need to think about in the enterprise environments, how can we run in this agent using the OpenShell sandbox technology with scale, and also how to control the blast radius, how to isolate the failure domains, those kind of problems. Here we summarize 3 patterns of running it. Pattern 1 is most straightforward, and all the agent process was running inside of the sandbox boundaries. So all the logic or the tool calling, you have to go through the security layer. It's well protected by the sandbox layers and policies. This is useful when you have a third-party agent. You don't want to modify the agent logic, or you cannot access the code to modify it, and it will just running out of box for you. And let's look at the pattern 2. Pattern 2 is different. The agent process is separate from the execution layer, let's say. The tool calling, the code execution, the generate code execution, etc. in this scenario. You can also notice that in the pattern 2 that it is more, it can running in a scale way, either per sub-agent or per tool calling. You can have a separate agent sandbox environment. You can run it parallel as well. And also, you get the benefits of failure domain separations. Let's say if there's a one execution sandbox is failure, it shouldn't impact the main agent process. So this is more flexible when you're architecturing this using OpenShell agent technologies. Pattern C, I will say, it's very close to pattern 2. The difference is that it utilizes some framework capabilities and it has a sandbox extension interface. And when you're using this, the developer don't need to provisioning those sandbox environment by themselves, and it utilizes the framework sandbox extensions. In my demo, it's a self-developed ops agent. I'm focused on pattern 1 and pattern 2. Okay, let's have a look at this pattern 1. There are more details in this diagram, how the component worked together. So on the left, you can see it's running on my laptop. I have a self-developed front-end COI tools called Agent Chat. It will accept users' requests. For example, I have a different scenario where I can set the different mode of the sandbox environment, and also I can send a request to my ops agent. So let's say I send a request called show me the date. It will pass to the OpenShell gateway. OpenShell gateway will start provisioning the sandbox part for me. Inside this sandbox part, it's running my ops agent. So as you can see, this purple box, the ops agent is a simple agent, can trickling the large language model and also integrate with embedded MCP tools to do multifunctions operations tasks. Let's say it received the user request of show me the date. It will start calling the tool calling to call Linux date command, and then it will interact with the Q1 self-managed large language model, and then format the output to the end user. But during this process, it will have to go through the multi-layer like landlog, the file system protection, and have to running on Linux security mode, and also go through the network OPA policies. And in the OpenShell gateway, you can also see multiple components over there. So basically, there is a inference router was configured, the large language models. And on the right side, you can see there is ops agent part without OpenShell. This is for comparison purpose. And later on, I will demonstrate all of that. And with that said, let's look at the demo scenarios.